City Learners TV, learning made simple.
Welcome back to class. So let's continue from where we stopped in the previous video. Okay, we have looked at the concept of factors, prime numbers, and prime factors. So in this video, we're going to be solving about 3 questions related to lowest common multiples using long division method. And as you can see on the board, these are the questions here. Find the LCM, lowest common multiple, of the following set of numbers. Question A, 6 and 8. Question B, 4, 9, and 12. And question C, 12, 36, and 90. And just right here, I have listed down on the board the prime factors between 2 and 20. These are the prime factors between 2 and 20. 2, 3, 5, 7, 11, 13, 17, and 19. These are all prime numbers that can divide a number without a remainder. And that is why we call them prime factors. We're going to be using the prime factors to divide our given numbers. And how are we going to do that? I'm going to simply do that by drawing. We are solving now question A. I will draw my long division line, and right inside the long division line, I put the two given number, 6 and 8, separating them with a comma, 6 and 8. And now this is the rule. I will start dividing the given number, each of them, using my prime factors, beginning from the least, from the lowest. And the lowest prime factors in this list is 2. And then I'll put my 2, it's a prime factor, to the left of the division line. Then I'll begin to divide the given number using the prime factor. So how many times will 2 divide into 6? That will be 3. Just to do a nursery mathematics a bit, let's count 6. 1, 2, 3, 4, 5, 6. And then we're going to cross out 2 and find out how many times 2 divides 6. So 1, 2, 1, 1, 2, 2, 1, 2, 3. That's how I got my 3. If you do the same thing for 8, you will find out that 2 will divide 8 how many times? 4 times. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 1, 2, 1, 2. How many times? 1, 2, 3, 4. 4 times. Okay. Now, should I proceed to use another prime factor? No. Before I proceed to pick another prime factor, I must ensure that the previous prime factor I've been using to divide can no longer divide any of the answers I have gotten. In this case, I have to look at the 3 and 4, which are the result of the first division. Can these two still divide any of them? The answer is yes. 2 is a factor of 4, meaning that 2 can divide 4. So I have to repeat 2 as my divisor, as the number or prime factor I'm using to divide. Okay, if I use 2 to divide 3, there will be a remainder. So because there's going to be a remainder, I will have to repeat the 3 and put my comma. But if I use 2 to divide 4, there won't be a remainder. I will get exactly 2. Okay, 2 will divide 4 2 times. Okay, before I proceed to another prime factor, I need to consider the same thing. With this same 2 that I've been using, will it divide any of the answer? Yes. So I repeat the 2. And you know, 2 will divide 3, but there will be a remainder. So because of that, I repeat the 3. And then 2 will divide 2 1 time. 2 will divide 2 1 time. So you can see, should I proceed to another prime factor? Yes, I can proceed to another prime factor now. Why? Because these 2 that I've been using can no longer divide any of the answers here without a remainder. 2 is not a factor of 3 and it's not a factor of 1. So in that case, I move to the next prime factor, which is 3. And 3 will divide 3 1 times, and 3 cannot divide 1. That will be a fraction. So in that case, we are going to repeat the 1, and that is the final answer. The moment you get 1, 1 after your last division, that is the end of the calculation. So what am I supposed to do next? I will look at all my prime factors, and multiply them together. I will write the LCM of 6 and 8 equals to 2 multiplied by 2 multiplied by 2 multiplied by 3. 2 times 2 is 4. 4 times 2 is 8. And 8 times 3 is simply 24, being my final answer. We move to the next question. Okay, for question B, I do the same thing, the same steps I followed, drawing my long division line, and then the given numbers are 4, 9, and 12. I place them inside, separating them with a comma, 4, 9, and 12. Okay, I'm using my prime factor to divide, beginning from the smallest. And I have to find out if the smallest, the first prime factor, can divide any of the given number. And as you can see, the question we have now has 3 sets of given numbers. So the first prime factor can divide 4 and can divide 12. So I'm going to use it. 2 will divide 4 2 times. 2 will divide 9 4 times, but there's going to be a remainder. So because of that, I repeat 9. That means 2 is not a factor of 9. 2 will divide 12 6 times. Okay, the next division, will 2 still divide any of the result? Yes. 2 will divide 2 1 times. 2 will not divide 9 without a remainder. So we repeat the 9. 2 will divide 6 3 times. Okay. Can 2, being the prime factor we are using, still divide the answer without a remainder? The answer is no. 2 cannot divide 1. If 2 divides 9, there will be a remainder. If 2 divides 3, there will be a remainder. So I move to the next prime factor, which is 3. Okay. 3 cannot divide 1, so we repeat 1. 3 will divide 9 3 times. 3 times 3 is 9. Okay. And 3 will divide 3 1 time. So the next is, I'm still going to use the same 3 because 3 can divide one of the answer. Okay. 3 cannot divide 1. We repeat 1. 3 can divide 3 1 times. And 3 cannot divide 1. We repeat 1. Like I said before, once you get 1, 1 or 1, 1, 1, depending on the set of number you were given, once you get 1 as the last result, that is the end of your division. So what are we expected to do? We are going to multiply our prime factors together. So LCM of 4, 9, and 12 equals 2 multiplied by 2 multiplied by 3 multiplied by 3. And the answer is the LCM of 4, 9, and 12. 2 multiplied by 2, 4. 4 multiplied by 3, 12. 12 multiplied by 3, 36. So 36 is the LCM, lowest common multiple, of 4, 9, and 12. We move to the next question. Question C. I'm drawing now my division line. Very neat and straight. And then my given numbers are 12, 36, and 90. These are my given numbers. Okay, then I'm going to simply start using my prime factors to divide. And the first thing to consider is the least prime factor, which is 2. Can it divide any of the given number? The answer is yes. Okay, so I'm putting my prime factor here to divide. 2 will divide 12 how many times? That is going to be 6 times. 2 will divide 36 how many times? Let's split 36 into 3 and 6 and divide it one after the other using the prime factor. 2 will divide 3 how many times? 1 time, but it's going to remain 1. Put that 1 at the back of the next number to make it 16. Please, that remainder, do not add it to make it 7. Simply put it at the back of the next number. That will make it 16. Then how many times 2 goes in 16? That will be 8. So 2 goes in 36, 18 times. You can clean this up in your rough book. And then how many times 2 goes in 90? Let's apply the same method. 2 will go in 9. How many times? 4 times. 2 times 4 is 8. So 2 goes in 9 4 times to remain 1. Remainder 1. That one, put it here to make the next number 10. Not to add 1 to 0 and get 1, but to put that remainder at the back to make it 10. So how many times 2 goes in 10? That will be 5. 2 divides 90 45 times. Okay, we move to the next division. Let's consider if the same prime factor can divide. Of course it can, because 2 will go in 6 3 times. 2 will divide into 18 9 times. And 2, can 2 divide 45 without a remainder? No, there will be a remainder. So we repeat 45. What next? Can 2 still divide any of the results without a remainder? No. We move to the next prime factor, which is 3. Okay, 3 will divide 3 1 times. 3 will divide 9 3 times. And can 3 divide 45 without a remainder? Yes. Let's plate it. The same method we used when we were dividing the first row. Let's try the same method here. 3 goes in 4 1 times. Remainder 1. That one, put it in front of 5 to make it 15. I repeat, not to add it. If you add it, it will be 6, and that will make your answer incorrect. So add that one behind the 5, and that makes it 15. 3 goes in 15 5 times. So the number of times 3 divide 45 is simply 15 times. Can 3 still divide? Yes, of course it can. 3 will not divide 1, so we repeat 1. 3 will divide 3 1 times, and 3 will divide 15 5 times. Can 3 still divide any of the results without a remainder? No. So we move to the next prime number, which is 5. So 5 will not divide 1, we repeat it. 5 will not divide 1, we repeat it. Always separate your results with comma, okay? And 5 will divide 5 1 times. And I've told you, once your final answers are set of 1, you have arrived at the answer. So what next are we supposed to do? We are going to multiply all our prime factors together to get the LCM of the set of given numbers. So the LCM of 12, 36, and 90 equals 2 times 2 times 3 times 3 times 5. And that will be what? 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 5 will give us 180. And this is the final answer. 180 is the LCM, the lowest common multiple of 12, 36, and 90. I encourage you to look for more questions related to LCM using long division method. In that way, you improve your studies. So I'm going to end this class here. Kindly subscribe to this channel, click on the notification bell, and ensure you share this channel with other friends. In that way, you are extending what we are doing, and you are also supporting us. Thank you very much. Bye.